You know how I've been harping on you constantly about that dy dx, that differential, whatever you put that in there for your integral? Because, ladies and gentlemen, here it is. The disk and washer method about the y-axis. Not everything revolves around the x-axis. We have to be open to what's going down and what's happening here. So here is your disk method. So your disk method is literally the same. We're not getting anything new method here. It's just a matter of the variables. I'm going to integrate from c to d of pi f of y squared dy, where c is less than or equal to y, which is less than or equal to d. Hello, somebody. Are you out there? Why? This is in terms of y. Your differential is important. It tells you the variable that you're integrating around so that you can work with it. But notice this is still the area of a circle. Nothing's changing there. It's still pi r squared. The difference is if I'm looking at my r that I have, I'm going here from c to d whenever I have this, whatever it is that I have, and then I'm going to be revolving around that thing. All right, so I don't even know, you guys. From this shape. So if I'm looking at this shape, oh, doggone it, I keep hitting that thing. Then I'm looking from here, and this is going around the y-axis. So I've got this shape that I'm looking at. Do you see what's happening there? So instead of going around the x-axis, I'm just swinging this thing around the y-axis so it looks more like a dish or a bowl rather than on the side that we did with the x. It's coming up here and it's looking like this. This is the disk method, means it's solid and filled in. So I've got a bunch of these circles, but it's f of y, so my radius is coming out from my y-axis. No problem. You can do that. All day long you can do that. By that same rationale, let me get rid of this little fellow there. By that same rationale, if I wanted the washer method, then I'm going to have volume is equal to, I'm still going from c to d, of pi, but whenever I'm looking at this one, I have f of y squared minus g of y squared dy. Everything is in terms of y. But when I'm looking at this is the same concept. This is still the outer radius, and this is still the inner radius. But when I'm looking at that outer versus inner radius, I'm talking away from that y-axis. So if I have this, whatever it may be, this function, zoop, and this function, zoop, right, whatever, and I'm going here is d, and here is c, whatever this is. It's going from here. This is my f of x function, and this is my g of x function. Outer meaning farthest away from that axis. That's what I mean by outer, right? Farthest away from that axis, and then closest to that axis, because you're still doing the same thing. From here to here is my radius. So I want to take this whole big huge area, subtract off this bottom area so that you have what's left in the middle. Same concept. The only difference is everything is in terms of y because I'm looking at the y-axis. All right, that's why it's so important whenever I'm looking at my variables and you have this differential that tells you how you're playing this game. All right, but it's the same formulas. that it was before. I'm not changing that up at all. We still have a circle, right? It's still pi r squared, that area of the circle, but everything is in terms of those y values. So everything now has to be in terms of y. So pay attention to that part. Okay, if you're going about the y-axis, everything is in terms of y. If you're going about the x-axis, everything is in terms of x. For the disc and washer method. Right? For the disc and washer method, whichever axis you're revolving around is the same variable. Okay, let's try and